this video, we're going to talk about acceleration, and we're going to figure out what it is and what are some characteristics and important features about acceleration. Acceleration is defined as how quickly the velocity changes. And it's important to understand that it's the velocity and not the speed that defines the acceleration. When trying to understand why it's velocity, think about what you feel when you accelerate. There's 3 different times you might accelerate throughout the day. One time you might accelerate when you speed up. That's what we mostly think about when we're accelerating. And when you speed up, you feel pulled backwards. Even though you accelerate forward, you feel some kind of a backwards pull as you're doing so. Another time you accelerate, sometimes we call this a deceleration, but in physics, it's still considered acceleration. And that is when we slow down. As you slow down, you accelerate backwards, and you feel this forward pull, forward push, as you do so. Now, there's one other time as you're driving or you're moving around that you might feel a pull, and it's not a pull forward or a pull backwards, but a pull side to side. And you feel this pull side to side when you turn or change direction. So acceleration can be when we speed up, when we slow down, or when we change direction. And it's this changing direction that makes us have to define it as the velocity and not the speed. Because let's say you're going around a turn, and you go around that turn at a constant 20 miles per hour. So even though your speedometer says that you are not changing your speed, your direction is changing. First, you're going forward. And so you might be moving at 20 miles per hour, let's say north. Then a little bit later, you're moving at 20 miles per hour, but in this case, east. Those 2 values are actually different velocities. They are not the same velocity. Even though their speed is the same, because the direction is different, the velocity is different as well. Because velocity not only is speed, but speed with direction. So when we define acceleration, we have to talk about how quickly the velocity changes, because even if you change direction and your speed stays the same, you are accelerating. So now let's look at an acceleration and see what this means. So let's say we have an acceleration of 5, and the units are a meter per second per second. What does it mean to have an acceleration of 5 meters per second per second? Well, it means that the velocity is changing by 5 meters per second every second. That word per really means every. We can replace it with the word every. So in this case, the velocity changes by 5 meters per second every second. So if we start at a velocity of 0, after 1 second it goes up by 5. It increases by 5. After another second passes, it goes up by another 5. So now we're at 10 meters per second. After another second, it goes again up by 5 to give us 15 meters per second. Now, acceleration can also be negative, and that negative tells us a direction. So what happens if we have a negative 5 meters per second for an acceleration? Well, that means that the velocity again changes, but it goes down by 5 meters per second every second. So instead of increasing by 5, it would decrease by 5. So again, if we look at the velocity as a function of time, if we start at, let's say, 20 meters per second, after 1 second, it has now gone down to 15. After another second, it is now gone down to 10. And after another second, it is now gone down to 5. So in this case, our velocity is going down by 5 meters per second every second. The next thing that we want to look at is how do we calculate this acceleration and what are the units? Well, the acceleration, again, is the change in velocity, how quickly it changes. So that's a rate of change. It is the change in velocity divided by the change in time. Remember that this delta, which is represented in math by a triangle, this Greek letter delta means changing. If we start at, let's say, 20 miles per hour, and we increase to 25 miles per hour, well, then our change in velocity is 5 miles per hour. Likewise, though, if we start at 35 miles per hour, and we decrease our velocity to 25 miles per hour, that means that our change in velocity is negative 10 miles per hour. So we can, again, decrease that velocity. It just means that it would be a negative change in velocity. As we described, our units are meters per second per second. We can abbreviate that. A lot of people write it instead because there's 2 seconds written. We say it's meters per second squared. Now, looking at this idea of the velocity kind of increasing or decreasing, one might come to, unfortunately, say that a positive acceleration means we speed up and a negative acceleration means we slow down. But I want to say that that is not the case. It does not necessarily mean, positive acceleration does not necessarily mean we speed up, and a negative acceleration does not necessarily mean that we slow down. Let me elaborate on that. Okay, so here's all the possible combinations of when things could be positive and when they can be negative. So we're going to look at what happens when the velocity is positive and the acceleration is positive. What is our overall effect? Do we speed up or slow down? And then let's look at what happens when the velocity is positive but the acceleration is negative. What is the overall effect? Do we speed up or slow down? And then finally, if the velocity is negative and the acceleration is positive, or if the velocity is negative and the acceleration is negative, do we speed up or slow down? So let's first look, let's say that we start, in that first situation, we start with a velocity of positive 10 meters per second. So we start with a positive velocity, and our acceleration is also positive. Let's say that it is a positive 1 meters per second per second. That means that the velocity goes up by 1 meter per second every second. So now let's look at time and velocity as a function of that time. So let's say at 0 seconds, we start at positive 10 meters per second. And what that positive means is it simply means to the right. Remember, the positive and negative of velocity tells us a direction. So I'm going to put in parentheses that this simply means 10 meters per second to the right. I'll put an R for right. Now, after 1 second, the velocity is going up by 1. If you look at your number line, you go from 10 and you go up 1, you go to 11. And that means that we are 11 meters per second to the right. After another second, we are now going up by 1 again. We are at positive 12 meters per second, or 12 meters per second to the right. Now looking at the speeds, speeds don't have direction. So looking at the speeds, we have gone from 10 to 11 to 12 meters per second. So clearly in this situation, when the velocity is positive and the acceleration is positive, we are going to speed up, which is what you might have expected before. Now let's look at a situation where the velocity is positive and the acceleration is negative. So the only difference that we're going to do here is I'm going to change this from a +1 acceleration to a -1 acceleration. So that means that the velocity goes down by 1 meter per second every second. I started at 10, that means 10 meters per second to the right. And now I'm going to go down by 1. So after 1 second, I went down by 1, I went down to 9, which means 9 meters per second to the right. And again, after 1 second, I go down by 1 again, I go down to 8, which is 8 meters per second to the right. Looking at our speeds, and again, our speeds are only the numbers with the units, not the directional part. We see that my speed goes from 10 to 9 to 8. It has gone down, we have slowed down. Again, that's probably what you expected. But now let's look at another situation where the velocity and the acceleration, well, in this case, the velocity is negative and the acceleration is positive. So the velocity is -10 meters per second, which simply means 10 meters per second to the left. Negative simply means left. Now you got to think of your number line here. Here's 0, here's -10. Okay, so if we look at our number line, we're going to go up by 1 meter per second every second. So I start at -10. If I go up 1, I've gone to -9. That means I'm moving at 9 meters per second to the left. After another second, again, I've gone up by 1 meter per second. And if I go up by 1, I've now gone to -8. Which means I'm going at 8 meters per second, again, to the left. Looking at my speeds, I've gone 10, 9, 8. In this situation, I've slowed down. Maybe not what you expected. So in this situation, I have a positive acceleration, and yet I'm slowing down. Now, before we start to look at an overall general trend, let's finish this up where both the velocity and the acceleration are negative. So in this case, my velocity is going down by 1 meter per second every second. If I start at -10, then I go to -11, So I go down by 1, I have to go down this way, so I go to -11, and I go down by 1, I go -12. And again, this means 10 to the left, 11 to the left, and 12 to the left. We see that my velocities, or my speeds, are going 10, 11, 12. In this case, I am speeding up, even though I have a negative acceleration. So what is the pattern here? Well, we see that these two are speeding up. And notice that they are the same direction. So when the velocity and acceleration are the same direction, we speed up. And when they are opposite directions, when one is positive, one's negative, doesn't matter which one is which, that means that we slow down. So again, positive and negative acceleration doesn't necessarily mean speed up or slow down. You have to look at how it compares to the velocity. If they're the same direction, you speed up. If they're opposite directions, we will slow down.